Let's look at the physiological classification of neurons. Physiologically, neurons can be classified into two types. You have the motor neuron, also known as the efferent neuron. And then you have the sensory neuron, which is also known as the afferent neuron. Physiologically, neurons can be classified into two types. One, motor neuron. Two, sensory neuron. So let's begin with the second one, sensory neuron or afferent neurons. These type of neurons are neurons that carry impulses or information from all of the body parts to the brain. I say this type of neurons are neurons that carries impulses or information from all of our body parts to the brain or the central nervous system. Okay? Sensory neurons. So these neurons are the ones that help us to sense or feel things. For example, the sense of touch. I was explaining the other day that if you touch your neighbor, the person will feel it. The person knows that something is touching. Alright? And that's because there are numerous touch receptors and sensory neurons around the skin. And that is how you have this perception of touch, of feeling. It is these sensory nerves that are around the skin that will carry the information from that area. Whether the person is touching you on your laps, or the hand, or the face, any part of the body. These sensory neurons carry the information to the central nervous system, the brain. Okay? And the brain interprets. It tells you the type of touch, whether it is crude touch, whether it's a romantic touch, whether the touch is harsh, whether it is sweet or dangerous. And the brain, after interpreting it will send down motor commands. No, it will send down information back to that part of your body. And these information that are sent, or the motor commands that are carried from the brain to all of your body parts, is done by the efferent neurons or the motor neurons. So what am I trying to say? Why the sensory neurons carries impulses or information from all of the body parts to the brain, the motor neurons carries information or impulses from your brain to the body parts. That is how things work. Okay? But there's another one, which is known as interneurons. We are looking at physiological classifications of neurons. And I said, here you have two, but there are supposed to be three. Alright? So we have talked about the motor neuron and the sensory neuron. Number three is the interneuron. Interneuron. Should I spell that one too? Yes. Which one carries information from the brain to other parts of the body? Motor neurons carry information from the brain to the body parts. Sensory neurons carries information from body parts to the brain. Alright? Good. Any other question? No. Number 3. Interneurons. The interneurons are neurons that connect the sensory neuron and the motor neurons. Interneurons are neurons that connect the sensory neurons and the motor neurons. And then we have other types of classifications depending on the length of the axons. Alright? But let's leave that. We shall now go to properties of nerve cells. Properties of nerve cells. Properties of nerve cells. On the slide, I already listed all of the properties of neurons. First is that they are excitable. Okay? Excitability is one of the properties of neurons. So they are capable of being excited. If you want to excite the touch neurons on your skin, alright, you want to excite it, you simply touch someone. You see that neuron becomes stimulated by the touch, and then it begins to walk, it begins to carry that information to the brain. So they are capable of being excited. Alright? Excitability. As we proceed, we are going to do excitation of nerve cells. In fact, you are supposed to understand the excitation of nerve cells, muscle cells, skeletal muscle, and the heart muscle. And that is when we get to action potential problem. So, excitability is one of the properties of nerve cells. We have conductivity. They can conduct, carry information from the parts where they are being excited to the brain and even back to the point of excitation. And then you have others such as refractory period, summation, adaptation, fatigability, and all or none law. All or none law. All these things fall under excitable tissues. Right? Muscles, physiology of the nerves and muscles. That's what we are doing now, talking about now. So, we have talked about types of neurons, right? So the properties, you go and look at properties of nerve cells. Okay? I've already done that on the slide. So when you go home and you read about properties of nerve cells. So we now have to look at action potential of nerve cells. Nerve action potential or membrane potential. Membrane potential of neurons. Membrane potential of neurons. When we are talking of membrane potential, we want to look at how neurons are excited and how they generate action potential and return back to their resting states. So membrane potential is divided into two parts. You have the resting membrane potential and action potential. Membrane potential is divided into two parts. You have one is the resting membrane potential and two is action potential. So what is resting membrane potential? Resting membrane potential. Resting membrane potential is the potential difference that exists between the ECF and ICF of the membrane. The potential difference that exists between the ECF and the ICF of the membrane is either the nerve cell membrane or the muscle membrane or the heart membrane. Alright? Good. During resting membrane potential, the interior of the cell, during resting membrane potential, the interior inside of the cell is negatively charged. During resting membrane potential, the interior of the cell is negatively charged, while the exterior of the cell is positively charged. So there is electronegativity inside of the cell and electropositivity outside of the cell. Is anyone lost? For example, you have a cell. Alright? Let's take this as the cell. During resting membrane potential, you have more of negatively charged ions inside the cell. Okay? So there is electronegativity inside of the cell. And outside the cell, there is electropositivity. So you have more of positively charged ions outside the cell. Alright? So when a cell is at rest, the interior of the cell is negatively charged, whereas the exterior of the cell is positively charged. This occurs, or it applies to all cells. Okay? Whether it's a nerve cell or muscle fiber or whatever. The point you need to note is that there is electronegativity inside of the cell and there is electropositivity outside the cell. But then, when the cell moves or there is an alteration of the polarity or the resting membrane potential of the cell when there is an alteration. The interior of the cell becomes positively charged, while the exterior of the cell becomes negatively charged. So there is a change of polarity. If, for example, you have the axon of a nerve cell, alright? And inside this nerve cell, you have more of positively charged ions. Right? And then outside, you have negatively charged ions. It means that there is a change of polarity of the cell, where the interior of the cell becomes positively charged and the exterior becomes negatively charged. So at this point, you will say that depolarization has occurred or action potential has occurred. So an alteration in a cell polarity or alteration of resting membrane potential, in which the interior of the cell becomes positively charged and the exterior of the cell becomes negatively charged, is said to be action potential. So I was saying that look, membrane potential is of two types: resting membrane potential. Alright? And I said resting membrane potential occurs when the inside of the cell is negatively charged and outside is positively charged. The second one is action potential. Action potential. Action potential is the alteration of the resting membrane potential. An action potential is an alteration of the resting membrane potential in which the interior of the cell becomes positively charged while the exterior of the cell becomes negatively charged. We will look at all of the stages of action potential. But before we go into that, we need to know the reason for electropositivity and electronegativity of the nerve cells. Okay? So we have types of ions found in the neurons. Okay? You have positively charged ions, also known as the cat ions, which are mainly sodium ions and potassium ions. Okay? Ions. And then you have negatively charged ions, which are also known as anions. And the main ion then is the chloride ion. Now look at this table. The ECN and the ICN. I believe you are done body fluid physiology. Yes, sir. So what is the ECN? Extracellular fluid. Found where? Extracellular fluid. found where? Outside the cell. Good. And then the ICM is the intracellular fluid, and this fluid is found inside of the cell. Now, between the extracellular fluid and the ICM, there are distribution of ions, both anions and cations, positively charged ions and negatively charged ions. So this table tells you the quantity or amount of ions that are found inside and outside of the cell. So in the ECM, sodium ion is more. It means that you have more sodium ions in a fluid that is outside